All right, now that the cockatoos have somewhat buggered off to another yard, we can have another go at doing this take. It's been quite a while since I've been out in the shed, been extremely busy, so much so that I have forgotten what I actually recorded last. In that time, I've also got new microphones, so you have to bear with me because they don't clip on like the old ones, and I'm afraid that I'm just gonna like continually muffle them, and all you're gonna hear is like, that was last Saturday night. So anyway, just looking at this, I can tell that last thing we did was crack the sound deadening out, and it's still laying in there, but that's fine, it can stay there. We also need to finish welding up that little bad boy over there where I ran out of gas and get this one done. And then the front part of the cage is locked in, and I need to do the rear legs and get them locked in. I need to do that urgently because I promised the front struts off of this, well, the ones off of that I put in this to a mate. So I need to get them out and shipped to him ASAP because I need to also get some other parts off that and send them out. Black Friday sales are coming up and I need money to buy struts for this. So I need to take the struts out of this to afford to buy struts for this. Yeah. But anyway, once I get the cage welded in, I really don't need it to be sitting on the wheels anymore. So rear legs, front struts out, other parts from that out, money in, new coilovers for this in the mail. So we need to get the new gas cylinder on the welder. Eeny, meeny, miny, mo. This one will do. We'll get that on here, and we'll get to welding. And one of these days, I'm actually gonna build a proper welding trolley. Let me know in the comments if you want to see that. Comments. Anyway, look, we got work to do. Let's do it. Didn't see you there. Sorry. I thought it was time to switch to water. Anyway, I got that one welded in down there now, and I fixed up that other fella over the other side. Didn't record any of that because you guys don't deserve it. Like 70% of you aren't even subscribed, so what are you gonna do? Unsubscribe so I didn't show you some welding footage? Give me a break. But anyway, seriously, the reason I didn't record it is because the cricket's on and I can't record and listen to the cricket at the same time. But anyway, that is done. I need to get these rear legs in. So first things first, I need to do base plates. Now, as I've mentioned previously, this perfect spot here is no good. We need to move into here. And I want to push it out as far as humanly possible. And I need to get some better light in here. This is bad. Let me get more light. I'll come back. Okay. Light has been procured. Gimbals have been disciplined. So, as I was saying, this perfect spot here, which has already got a strengthening ribbon and is no good, it's past the center line of the axle of the vehicle, which the cage has to be within the center line of the axle of the vehicle. So that is about here somewhere, and I'm going to go back to there. So this is obviously a seat mount. It is also on the other side about where there's a rear subframe pickup point. The other one is there. So it's pretty strong here. However, obviously it is not flat. So I'm going to make a plate which probably bridges this gap here. Runs maybe from there to there, across over to here, and I'm going to make it sort of drop down in there. Probably going to be pretty difficult to bend that, so I might end up doing it in 3 pieces and welding it together. Rulings just says that that bar has to be straight, has to be as close to the internal body panels as possible, has to mount at the roof line within 100 mil of that bend, and can't be below that. So it has to basically be between that bar and pretty much there, like 100 mil from the bend. It's where it has to mount, and it can't have a bend in it. So it doesn't say that it can't kick out sideways like that. If I was triangulating it, I'd be fine with that. However, I don't really want to triangulate it. I really would love to run a rear triangle in here. It looks tough as, but for this car, it's just a visual thing. I don't need it. I don't need that kind of strength. It's not that fast, it's not that heavy. It's quite a bit of weight. It would look cool though. Let me think about this, and I'll do it tomorrow. Cool? Cool. All right. Slept on it. Decisions have been made. I'm not going to put the rear X in. Simple reason is if I put an X in the rear legs, then to make it work, I have to also put an X in the center. That's like an extra 8 kilos of tube. Yeah, it looks cool. It's, as I said, it's totally redundant, and it's also a lot of bar work in the rear of the vehicle. It's basically the rear of the cage would be stronger than the front of the cage because I haven't built the front of the cage to that kind of level. You know, if I was going to do twin X's in the rear end, then I would also run, you know, a bar from there to there, bracing that, probably one along the sill and then back out to the front to, you know, run all that together. You'd probably also run a bar across the floor, you know, and basically make it an entire like space frame, time attack, you know, enclosure. I would also run double door bars instead of an intersecting door bar because, you know, it's kind of a weaker design, but it's the one I prefer and it's easier. So lots and lots of reasons for not doing the rear X, unfortunately. As much as, you know, I'd like to do it, it doesn't make any sense. I don't need it. It's a lot of extra weight. We're pushing ahead. So I'm going to join where the front legs join because that makes everything nice and strong, and I'm going to push out as wide as I can. I prefer my, you know, rear legs to be straight and not off on an angle. Reasons, I don't know. Logically, you know, a bar is only stronger in a straight line if that's the direction that you're taking the impact from. So what's to say you're going to be taking an impact that's not on that angle and that bar's going to be perfect for it? Who knows? I had a look at a bunch of pictures. Like, it's quite common that the rear legs kick out on a side, and you know, I didn't hate the look of it. I thought I would, but I don't. So there's really no reason to keep them straight. I've just, like I said, I've just always done it that way. So I'm going to kick them out. The reason that I'm kicking them out, as I said, is because if you have a look at my seat mounts, which are there, and then you have a look at sort of where that point there is, where it's nice and flat and lines up, you know, up there. The harnesses sort of want to come through here really, really close to this rear leg, and I can't, if I put the harness bar in here, the harness is kind of off on an angle. Like it's actually a bit more extreme. Like it's, if you're on the wrong angle, it's sort of there, kind of like that. And you can see this, the rear foot mounting is sort of behind the seat, and the harness, yeah, I'm overcomplicating things. The harness doesn't work with the rear leg in my old car, where it was. That's why I had to put that funky harness bar in, which I didn't like. I can't put the harness bar in the main hoop because it's too close to the seat, and harnesses have to pull at a very specific angle with a hands device. And basically, if I need to adjust the seat up or down, I can't do that. I'm locked in exactly where it is, because the closer you are, the more angle change happens with a slight adjustment of the seat. Whereas if I bring the harness back to here, it's less than ideal. Ideally, you do want the harness to be locked in as close to the seat as possible, but this gives me more options. I can move the seat up and down 10 mil and only change the angle of the harness by like a degree, as opposed to if I move the seat up and down 10 mil when the harness bar is right behind it, I'm moving it by like 5 degrees. I very quickly get out of spec. So I want to pull the harness bar back. I don't want to have to do that same funky thing that I did last time. And I want this leg out as far as possible so the harness can pull straight back to where it needs to. Is pretty much the reason for this whole dilemma that I'm running into here. So I'm going to go with that. That's what I'm going to do. It was the original plan. Stick to the original plan. Let's do it. This is where we're at. So I got the midpoint of the rear axle. I ran a level up the outside here from the center of the wheel opening, and luckily I could see through here that there's you could see the indent on the inside here, which is this indent here. And I worked out that basically center line of the axle is about there. ran that down. So I've ran my plate past the center line because I want to pick up this strengthening point here, and I've done that. So the tube's actually going to sit inside that line, so it's going to be within the center lines of the vehicle. Now, when I've welded this, you can actually see it's pulled these two seams apart. So I'm going to have to come back and stitch those two seams together, but that's not a big deal. And I've put some little triangles in here to pick up this here, and that's good and strong. Okay, so this is a pretty basic tube, but it's still not foolproof. So I've got a string set up. You could probably just use some sort of straight edge if it happens to be the right length. If this tube is a little bit long or a little bit short, it's not a huge deal. Because it's a triangle, yeah, get close, but don't stress it too much. Now, first thing and the easiest thing is your floor. It's just going to be a straight cut through the tube, nice and flat, done with a grinder, or if you've got a bandsaw is better. And it's just a simple inclinometer measurement. Ground is 0, tube is 52 degrees. So I'll just smash a cut through at 52 degrees. You can also use one of these guys. You can use one of these guys. Up the top there is a little bit different. I don't know how well you can see up there. Now, you can intersect the top of the roll hoop straight on, like so, and that means that it would just be 90 degrees to the flat that you've cut here. Presumably, if your floor is level, measure the floor, measure the roll cage. If they're the same, it's just a 90-degree notch. If it's a few degrees out, then it's a few degrees out, but it's simple. Chances are, however, you're going to intersect on this curve like I am. You want to aim to intersect with your rear leg directly opposite your front lateral bar. It is the strongest. If you can't, for whatever reason, you just get as close to it as possible. You need to be within, this bar needs to be within 100 mil of this bend, and your rear leg needs to be within 100 mil of this bend. So you theoretically could have this tube here, down there, and then your rear leg up there, which is going to put a lot of twisting force on that main hoop in a rollover. So it's less than ideal, but can be done. I've got the option too, so I'm going to run my tube directly into this one. So I've got the string set up at the top of that, and it comes through to the back, like the furthest point that my tube can come out, which will be the back of my flat cut. I know those points and I can set a string to them, that's fine. I also know the short point, which would be great because my notcher cuts from the short side to the long side, and my short side is obviously the bottom of that tube, but I don't know where the short side's gonna land lengthwise out here. I mean, I could work it out, I could do the maths, but it's extra work and I don't really need to. I can mark the long point in the notcher, so I can get my long point and my long point, cut this flat first, mark up to my long point, put the tube in the notcher at the long point, and then just run a straight edge along the hole saw and just sort of project it out till I get to my dot. Now the angle of that, obviously it's coming through on two different angles. So there's an angle cut, it's sort of offset, but this tube is going up at an angle and the roll hoop is coming down at an angle that way. But it's also rolling off to the side. So we need to know both of those and how they affect each other, essentially. The angle of rotation for the notch is the easiest thing. So if we imagine that we've cut the flat on the tube and it sits like that, the throat line comes through just by eye, something like that. So the tube comes in here and out here, and we can measure that quite simply with this guy here. I know that my plate is flat on the floor, so I can put this right up here where I want the intersection to be, and that measures 42 degrees. So once I've got my flat cut on the tube, I can put my tube guide on it like that. I can rotate the tube 42 degrees in the notcher, which is there, and then I can run my notch through, and I know that my throat lines will line up. The angle back is the difficult one to get, and I have found this guy here is pretty much the best. just because there's not a lot of room up in there to use like these big fellas. Alternatively, surely you've got some offcuts lying around. Either run a notch through it at kind of what you think the angle's going to be and hold it up in there and check it, and then grind a few mil out and just keep going till you get it right, or wing it and hope for the best, depending on how much leftover tube you've got at this point and how many goes you want to have at it. You know, this is obviously a lot more work, but you're guaranteed to get it right. Measuring it may or may not work because I need to get the angle of this exactly right, because if I'm there and I set my angle to the string, which right there like that is perfect, if this isn't on the exact throat line, if I rotate it around to there a little bit, all of a sudden it's not right. It needs to go out to there. If my throat line's on it, then my throat line's actually here, then it needs to be there. Like it's drastically different if I don't get my throat lines right. So I need to really line up the straight with my throat line, which is where my tube comes in and goes out. So it's there. And then I need to get this down to the angle of the string and then get it like that. Tighten that off. Now I know that this one's not right, but just by holding it up here and having a look at it, it's pretty good. There's about a, let's say it's about an 8mm gap on the back side here. So if I sit this on this tube and there's about an 8mm gap, I'm pretty good. It's a bit more, it's about a 10mm gap. So I'm pretty close. If I cut at this, I reckon I'm probably gonna have to grind a little bit out of the bottom, which isn't the worst thing in the world. And I can now use this guy here if I want my actual angle. Otherwise you can take this over to the tube notcher and set it to it. Going up. Men's underwear. That's going down. Whatever. That angle is there. 57.2 degrees. See, I don't know, that's way off. I reckon it's closer to 8mm off is about there. I reckon it's closer to that, which is 49 degrees. Let's set this to 49 degrees and see what happens. This is why I double check things 3 different ways, because I don't like making mistakes. So I'll set that to that and see what it looks like up in here. There and there. Yeah, see that? The more I rotate this, the more it looks good. Like rotating it this way. So I'm gonna trust the physical tube more than my measuring shenanigans. And I'm gonna trust that this is pretty good. And we're gonna run with that measurement. We'll see how we go. Let's do it. like this. So glad I went with my instincts on that there. I don't know how well you can see, but it fits up really nicely all the way around. There's a slight rotational issue here. You can see there's a bit of a gap on the backside there, like for that to sit down, the tube wants to rotate slightly. You know, like I said, my measurements, you're only ever going to get so close, but that gap is fine. If I really bothered about it, I could take a mil off of this side and drop it down. Distance wise, I'm great. I wanted to be just inside these spot weld lines, and I am. I'm hitting pretty square on the plate. Yeah, so I'm happy enough with that. It just obviously needs to be dressed and welded in. And also need to replicate it for the other side, which is the same thing. So the notcher is set up at the same angle. This cut here, when I cut the piece off of here, I'll reuse the other, that same angle for the other one. I didn't use my offcut because I've got another use for it. I decided to cut both of them out of there because I really need to use that tube up. As you can see, it's getting a bit, how you going? It's older, is essentially it. So, plus obviously I needed to cut 2 angles, then I can cut 2 out of 1. So, you know, work smarter, not harder. Happy with it. Make a replica. Just when I put it in the notcher now, I rotated this way. I want to rotate this way, and it should work, theoretically. If it doesn't, I'll let you know. Because like I said, I'm way too tired to be thinking. I'm probably not making any sense. But yeah, I don't care if I make these bars 2 or 3 times. I've got the material there to do it. If I have to do it, I have to do it. You might not. So like I said, just, you know, if it comes down to it, just cut both ends out of some scrap and tape them to a stick or whatever and make a mock-up bar. If you've got a 3D printer, you can 3D print those tube notching guides. They're fantastic. The files are everywhere online, and you use TIG filler rod, which is actually quite expensive gear, so I don't know why they choose to use that. You could probably use something else, bamboo skewers from your supermarket or whatever, like a couple of cents, whatever. They're great tools. There's lots and lots of great tools out there. I don't have any of them. I have offcuts of tube cut to different angles and different notches, and generally speaking, I use them, and I don't screw up often enough to facilitate spending, you know, $1,000 on tips and tricks when I only screw up like $50 with the tube every 6 months. It's kind of the way I look at it. So, again, babbling, tired, sorry. Need to get this in. Let's go.